Good evening, everyone. Thank you for coming to this RCEA event on the topic of the Belfast Transport Hub. To introduce myself, I'm Jenny Chu. I'm chair of the Railway Civil Engineers Association. And in my day job, I'm the engineering manager and temporary work coordinator at the Colindale Station project for Morgan Sindall. It's to rebuild and expand a tube station on the Northern Line in Northwest London, and it's also part of a step-free access project. This event will be recorded and it will be made available on the RCEA YouTube channel. The link will be made available to all attendees after the event. So to quickly introduce RCEA, if it hadn't already known, we are founded in 1921 and we exist to encourage the exchange of knowledge and experience between railway civil engineers. In 1997, we became a specialist knowledge society of the Institution of Civil Engineers, and we work closely with other engineering disciplines. We currently have over 470 members, and we have a program of a mixture of evening events like this one and lunch and learn events, either hybrid, in person and online, or online only like this one. To find us on the IC website, you can find us under Specialist Knowledge Societies, or you can Google the RCEA, go to our website here at rcea.org.uk, or go, as I said, go to the IC website and find us under Specialist Knowledge Societies. If you are interested to join us, this is our list of membership fees. We've kept the fees frozen for the last 6 years, and we've had to make a slight fee increase for next year, but it's still very affordable at £20 for normal members, £10 for young members, £7 for retired members, and free for student members. If you're interested in getting involved in our committee, our next committee meeting will be on Tuesday, the 28th of October at 5 p.m. and it's held online only on MS Teams. If you are interested, please email rcea@ice.org.uk. Our future events will be at the end of November on the Coventry Very Light Rail project at Coventry University Technology Park and online. I will be distributing the registration sheet and details after this event. And for our Christmas event, we'll be having a talk in the ICE headquarters on the London Liverpool Street Station transformation. We'll be serving mince pies and mulled wine. And for our future events for the next quarter, we are currently actively getting it ready, and we will be publicizing it once all of the details are confirmed. But we have events lined up for January to April of next year. And to introduce our speakers, we have Andrew Arnold and Lisa McFadden, who will talk about demonstrating safety and interoperability for the Belfast Transport Hub. And without further ado, I will hand over to you, Lisa.
Thank you. So my part of the presentation is to take you through the project and give you a bit of context and a bit of background. And I'll also hopefully explain why it was deemed a significant change, and also take you through all the elements of change that was part of the Belfast Transport Hub that is now known as Belfast Grand Central Station. Next slide, please. Yep, you can keep going. Thank you. So the Belfast Transport Hub is a major investment project, and it's located in the heart of Belfast city centre. A lot of the slides will give you a good context of where it's located and basically a better understanding, because I appreciate a lot of people on the call may not have been to Belfast and would not be familiar with the project. So it was our mission to deliver a transformation of public transport by providing integrated service which connect people and enhance the economy and improve the environment. Slide, please. So we know we cannot deliver to the same standards we delivered before. So we know we cannot solve all our problems with the same thinking we used when we created them, as Albert Einstein said. So the transformation was to basically build the largest integrated transport facility on the island of Ireland. And the photograph you can see today shows the scale of change. And it should be noted at this point, at no point did Ireland, or in TransLink, did we have a bus and rail integrated facility. They both very much sat as two separate businesses in our organisation, and it was very much key to what we did. So I'll take you through the project scope, which is on the next slide. So it was a new station with 8 railway platforms and 26 bus stands. It was an integrated bus and railway station concourse. It had self-service and ticketing machines. That was also a separate project running in parallel with this project. It had a new Northern Ireland operating centre that also was deemed significant and also had the same key delivery date. Renew all the signalling and telecoms nearly as far as Dunmurry, and new track layout of in excess of 4 kilometres. This allowed a lot more timetable enhancement, a relocation of the Enterprise train from Langan to Grand Central Station, and the provision of office accommodation, retail opportunities, media advertising, car parking, new busway bridge, all that infrastructure that is associated with a brand new station. We also are promoting active travel. So basically that whole carbon footprint and improving our sustainability was also key to what we delivered. And we wanted a fully accessible station, so it's safe for all to use, is a key point there. Next slide, please. So compliance to standards is key in safety, as we all know. The picture on the left you see on your screen was the existing track layout into Great Victoria Street. You could see there in an instance, there's quite a number of problems. You know, it's on a tight curve, very complex switches and crossing. You can see at the top of the picture, multiple of them, a large stepping gap. So you could see from an operational and a management point of view, there could be difficulties in managing that station. On the right-hand side is what we've delivered. We take the standards from today, we apply them. We know we want straight platforms, we want beautiful sight lines. And again, that just means better safety, less chance, and reduce the risk of any issues in the station. Next slide, please. I kind of touched this earlier. It was so important it was accessible for all. Things like tactile pavings and navi lanes were introduced into our design of the station. And that just means those who are visually impaired could move around the station with ease and very, again, safe for everyone to use, and it was step-free throughout. Next slide, please. Now, this was probably one of our biggest challenges, and Andrew will go through this. This is quite a detailed process to follow, and there was a huge supply chain that was to deliver this station. And a lot of that was basically trying to mentor, communicate, what does that mean and what do you need? The amount of evidence, the amount of information, documentation that had to be collated as part of this process to make sure we could commission successfully in 2024. So this was probably one of our steepest challenges, basically bringing everybody up to speed, what's required, what documentation, when, and at what point we needed it to pass to our department was crucial to the whole program and successful delivery. Next slide, please. So did it work? So we're now nearly operating a year since the first public train was operating out of the station. And the success of the station is very much evident today. We have exceptional customer feedback, and we've had no major safety incidents. And there's 96% of the customers love the station, have given us really good positive feedback to date. I can say there was a percentage of adding more coffee places, but I can assure you 3 out of the 4 retailers sell coffee, so you can't please all, I guess. It's good, no safety concerns have been raised. Next slide, please. This just kind of a photo shows the scale and the size of the station, just the footprint, and it's also in a quite urban site, which also gives a lot of challenges on the ground. Next slide, please. This slide is really important. Everything in red you can see is the new track layout. Huge changes. Everything basically to the right is the 8 platforms going into the new Belfast Grand Central station. Everything to the left is connected out into the existing P-way. And with this came a huge element of change. Simple things like bridge crossings from 308A need to be widened to allow the new track layout. New significant size of 2 signal gantries was required at the end of the platforms. Things like BS 9992 was introduced in the middle of the delivery, and then a new evacuation strategy was required at the bottom end of the platforms. So there was a huge amount of track change that was required. And the next slide, if we go through it as well, I'll just demonstrate how much change came in. Yeah, so this gives you context. So in the top left, you'll see the footprint in red there where the station is located. You'll see where Langan Station is over to the right-hand side and Belfast City Hall there at the top. Everything's within a 15-minute walk in city centre, so it's quite a little condensed city, but it kind of just shows where the scale of the works and where everything was required to be. The next slide, please. So the next slide kind of shows as well, basically was the operational side and commissioning that was delivered by Babcock. One of the key things when Babcock being used, they were a framework contractor. So they had a clear understanding of how to deliver and comply with safety regulations, which was also key. I think that's this picture of showing the first train coming in, which is also was a big milestone there in October. But again, it was one without its challenges. This was a design and build project, so from a CSM point of view, that posed quite a lot of challenges as well, because there's a lot of design elements that is running in parallel. Not everything comes to a nice sequential stop, and then you go to for construction. So there was a lot of working with Carriageway Rail on this project to basically, get multiple safety justification reports done, because of just the way we had to sequence the works, such as the blockades and the planning. We had a major blockade in summer last year, but also we had blockades prior to that in Easter and Christmas 2024. But we had to phase it so we could deliver it safely is kind of the key point. Next slide, please. This slide shows the scale and change that happened on the signaling and telecoms. I should also point out that this is phased in 2 phases from a safety point of view, safety justification. Phase 1 is everything we're kind of discussing in this presentation, but there is a phase 2 associated with the car parks that will be delivered in 2026. This shows on this slide the amount of signaling that obviously went all the way down to Dunmurry. And this was basically upgrading old infrastructure that was needing to be renewed. So a lot of S&T, a lot of P-way, and a brand new signalling centre was delivered as part of the railway systems. So a lot of change happening at the business at the one time. And Andrew will take you through how we successfully managed that as well, and the process that was followed. Next slide, please. Here's an overall kind of pictures of how we delivered on the railway side. This is more just to give you a feel of the scale of the job out there on the railway systems. Like for example, we've McCullough planters, panel lifters there in the bottom left, or Transing tamper in the middle bottom left. And this is looking at the up and down as you approach the station. But in this job, like there was 2,500 sleepers, there was over 18,000 tons of ballast that had to be moved. There was 4.8 kilometers of track. There's probably nearly 50 kilometers of cable drums used in this job too. So there's huge amount of works and on a large scale. And again, this is just to basically convey the importance of the amount of change that was happening on the ground. And the next slide, please. So there's nice a collective picture when we get to the end of the commissioning. It's always nice when you get to the end point on time and hit your target key date, and also get that DFI interoperability certificate sign off. But I think again, in today's world, we have to embrace technology, and that was key to our successful rail opening on the 13th of October 2024, and that was where a new timetable was delivered without a glitch. And a lot of that is because safety compliance and following the right process and the right steps, which we'll take you through on this presentation, was key to our success. At this point, I'm going to pass to Andrew.
Thank you, Lisa. As Lisa said, obviously with the BTH change, it was classed as significant under CSM regulations, and it was also classed as interoperable under RIR regulations. So just to give you a flavour of what those regulations are, next slide please. So at the top level, there's the directives, which are instructions from the EU upon all the EU member states, and these set out the goals that all EU countries need to achieve. These don't have any force until they're transposed into legislation by each member state, and that is the regulations that sit underneath these. So these can be made directly by the EU and apply across the EU. These regulations are legally binding and then come into force directly. If you just tap one on, John, that's fine. So the one more. The EU Interoperability Directive was established to ensure that there was common technical specifications for interoperability across Europe's railways and establish a common Europe-wide verification and authorization process. So placing into service new and upgraded and renewed infrastructure and or rolling stock. And the objectives of that is being to enable trains to travel unhindered throughout Europe and to have a common market for any rail system. The CSM regulations, they are, to ensure a high level of safety is maintained, and where necessary, any sort of reasonably practicable, improve from what it was previously, and again facilitate access to the market for rail transport services through harmonisation, so in ensuring a level playing field, mutual recognition, and also to prevent safety from being any barriers to trade. Next slide, please. So, and click on one, that's okay, there we go. So in terms of the CSM regulations, what do we need to do first? We need to define what the system is, undertake any hazard identification to identify any reasonably foreseeable hazards. We classify those hazards and we can filter out any of those which are considered broadly acceptable. So in terms of the hazard doesn't need to be managed any further. The ORR guidance gives examples on that, but it's quite a small list, things like meteorites, paper cuts and things like that. You don't get many that are classed as broadly acceptable, but it's there if for these small instances that you need it. We determine how we're going to manage that hazard. So is it going to be through codes of practice, use of similar reference systems, or explicit risk estimation? So that's for hazards for that. We could talk about if it's for a signalling system, if the hazard is it's a green aspect, when it should be a red aspect, which could lead to a train collision. How are we going to manage this? We could use existing technology, follow the signalling handbook, and use a IRCE, so that's the signalling license design, and then once you've constructed, do principles testing and use recognized products. So if you follow that process and follow the codes of practice, you then don't need to explicitly demonstrate that that you're not going to get a green instead of a red. You can demonstrate that through the use of suitable products. So the design's been done before. You can use that justification. So from that point of view, CSM can provide a bit of a shortcut from traditional risk estimation, because some of the work has been done previously. But if you have anything new, then we'll need to look at that individually. And then following on from that identification, we then establish what we need to do to manage the risks. So that's the safety requirements, and then we demonstrate the compliance with those safety requirements. Next slide, please. So in terms of identification of hazards, this was led by the safety team. So for Belfast Transport Hub, that was Ricardo Rail ourselves, but we did need support from the whole project. This involves everybody on the project. It's a process that needs the right people to identify the risk. You need to collaborate across the project. So it's involving the train, the operations guys, the maintainers, the people doing the design, the construction. All of the project team are involved with identifying hazards. You need that expert judgment on what is an applicable hazard, and it's not necessarily always black and white. In terms of identifying hazards, there's several different ways of that would work. But in terms of, you would have the focused activities, so that's your hazard workshops. So that's your whole group of people getting together and discussing what the various risks that they see are. But also, any individual could identify one and pass that through to the safety team as part of their design process. It's also key to note that hazard identification is continuous. It never, throughout the project lifecycle, it never stops. You could identify a hazard at any stage, and it's sort of key to bear that in mind. And it's also, any changes to the design may change the risks associated with that design. So if the design is changing throughout the process, or there's a change required, at the construction phase that needs risk assessing to confirm that the hazards, any hazards that might arise from that change, are appropriately managed and we've reduced the risk as far as reasonably practicable. Next slide, please. In terms of the interoperability, again, you need to define the system and the programs and understand what effects that has on the overall safety risk profile. So that includes things like work packages and stage works, what the program is in, and the project interfaces, what the authorization overview is, and any roles and responsibilities that the various parties have. And you know, in terms of the key safety risks, they also need to know who is assessing that as well. And then we need to define the TSIs that are applicable to the project. Obviously now in Great Britain, in sort of England and Scotland, we have the NTSNs, but in Northern Ireland, the TSIs remain applicable even after Brexit, and that's set out in the protocol on Ireland and Northern Ireland. So for Belfast Transport Hub, we were still complying with the TSIs. For BTH, we were needing to comply with the command and control signalling TSI for all the signalling changes, the infrastructure, and the persons of reduced mobility TSI, which now is accessibility, but for the Belfast Transport Hub, that is was still for the PRM TSI at that point in time. So these were identified as applicable to the change. However, for the CCS TSI, we were able to apply and gained an exemption under Regulation 13 due to the nature of the signalling changes being legacy system, and I'll go through that a bit more detail later. And then just click on a couple. And then so the structure of the change. So in terms of the authorization, that defines what modules the interoperability change will be assessed under. So that's how we assess how we've conformed with the TSIs. So that is for the assessor to we sort of tell the assessor how they're going to what modules they need to use to assess the change, and then we'll look at the TSI clauses that are applicable and also justify which ones are not applicable to the change, and clause by clause demonstrate compliance with those TSIs. Next slide, please. So who did we as the project need to demonstrate compliance to? So the Safety Authority in Northern Ireland, so for the BTH project, is the Department for Infrastructure. And with the change being significant under CSM, we also had to first get our safety demonstration approved under by the ASBO, and the compliance to interoperability assessed by the NOBO and the DBO. So they check. So the NOBO and the DBO checks the interoperability elements, and again, it's not an APBO in Northern Ireland because it's TSI compliance and not NTSN, and the CSM elements are checked by the ASBO. All of this, and then any changes that are needed to the TransLink safety management system would go through the operators, so the TransLink operations team, in order to ensure that any changes to that has been implemented prior to entry into service. And all of that information is then submitted to the Safety Authority, so that, as I said, the Department for Infrastructure, and they would provide, they provided us with the authorization to place into service. And at which point then we were able to hand the system over to the operations and maintenance to be managed as part of the day-to-day railway operations. So next slide, please. So as Lisa has discussed already, you know, the BTH change was a very complex change. So when we're talking about bringing into use a new station and all of the modifications to those railway systems, what does that mean really in terms of the railway systems? How do we define that change? Excuse me, sorry, just a second. So as well as the obvious railway systems like so this diagram is the systems diagram that we had for the change. So as you can see, there's many different systems that had to undergo change in order to bring the station into use. So we have the obvious ones like the tracks, the signalling, but there's also these sort of what I like to call sort of more unseen elements. So you've got the railway drainage, signalling posts, like the civils works, electrification and plant, and also the operations. And then within the station building, again, you've got the obvious civils and architecture, the main building, but also you have the smaller elements, so the wayfinding signage, your mechanical electrical systems, again, and any organizational changes that are required. So all these changes then, as we've gone through, Lisa, this is all interfacing with the surrounding urban environment, the bus station, the surrounding railway, the existing rolling stock, the signalling control, which for BTH that was also being updated in a parallel work stream. So again, lots of things to manage there. The existing infrastructure and again the operations and the people that are going to use the new system. So it is a very, very complex change. Lots of systems needing to integrate safely, and with the existing surrounding urban environment and railway. Next slide, please. So with it being such a that complex change, it can't happen overnight. So what does that mean from an integrated safety point of view? Well, we need to understand when that change impacts the operational railway, because that is the key point in time. We had different bits of the project impacting the operational railway at different points in time. The main works was built on a neighbouring brownfield site, so these elements didn't impact the operational railway till right at the end. So the authorisation for those didn't need to happen until that point. But we did have stage works which impacted the operational railway at the point of those stage works. So as Lisa said, there were stage works at the Christmas prior to opening, and also in Easter. So we had the various blockades where we had these stage works. So as well as any hazards around, within those stage works, we also had the temporary arrangements between those stage works and when the full change was brought into use. So we needed to consider hazards around that point. And a key challenge on the BTH project was justifying that the constructed change is safe to enter into use, and this can't be shortcut. This is, it's a period of time between when the old station is taken out of use within the main blockade, and the new station could be brought into use. So this was a disruption to passengers, and I think overall we managed this well with good communication to the public on what was happening. So in terms of, next slide please, managing the hazards, we would need to define what system the hazard applies to, give a description of what that hazard is, what causes that hazard, so what risk, what elements could fail and that would lead to a hazard occurring, and then any consequences. So what would happen if that hazard were to occur? What would happen? Is the risk broadly acceptable? And if not, what risk acceptance principle are we going to use to manage that hazard, and who is responsible for managing that risk? So who we will, as the safety team, sort of liaise with in order to ensure that that hazard is appropriately managed. We'd have the existing safety measures for that hazard, so anything that is already happening and already being done to manage that risk within TransLink, that would fall under this. And then anything new that we could do in addition to those would be the potential safety measures. And then out of those potential safety measures, we would select the ones that we believed would, along with the rest of the team in the project, would manage that risk as far as reasonably practicable, and they would become the safety requirements. And then there's any actions around those, and then we would track how we're progressing against compliance with those through managing the status of those safety requirements and hazards. Next slide, please. So for BTH, we had 116 hazards. So this included things like station structural integrity, signalling errors, P-way integrity, platform trace interface, slip, strips and falls, operational errors, and I could go on, but I won't. So there's many more types of things, but this just to give you a flavour of the types of things that we are identifying as risks to the operational railway. The next slide, please. So we had to, and then we demonstrated that the integrated safety is managed through compliance with the safety requirements, and there was 408 of these for BTH. So that was both demonstrating that the hazard was reduced as far as reasonably practicable at both the design phase and the construction phase. So that might be 408 safety requirements, but we might need multiple pieces of evidence against that safety requirement for both, a bit for design and for construction. And we were ensuring that the safety requirements were covered aspects such as compliance with the applicable standards, any derogations to those, ensuring any systems that required to operate the station were provided. So that's aspects like radios for staff communication and CCTV for public safety. And then ensuring the critical systems continue to operate in degraded conditions. So, if, for example, loss of power, we're ensuring backup generators and uninterruptible power supplies were provided. And then demonstrating that the various systems integrated safely. So any systems that interface with other systems, ensuring they integrated correctly. And then provision of training, appropriate training for operational staff and maintenance. I'll touch a bit more on that later. Next slide, please. So for the stage works, we were also, as well as looking at the potential hazards during those stage works, we were also ensuring that any hazard between the interim time between when the stage works were implemented and the implementation of the final change was managed as far as reasonably practicable. And that's key, that it's to the operational railway rather than the construction site itself. So construction works managed under CDM regulations and not CSM. So for example, for the main blockade, we were having hazards around on-track plants, on-track machines entering the operational railway from the work site. So that could be a work trolley running away and entering the railway, a train entering the blockade work site, for example, if it was misrouted, and then consideration of what would happen where the passengers that would normally use the Great Victoria Street that had been closed, where those passengers would then go to use the rail service, so that the expected increase in passenger numbers at the surrounding stations. So these were the types of things that we would be managing for stage works for that interim period. Next slide, please. One of the other key things we were needing to ensure was being managed was any derogations to standards. So the first drawing on the left there is the optimal solution for the platform train interface. So the Northern Ireland standard gauge drawing defines a base requirement for the separation between the rail to the platform of 760 millimeters and a platform recess width of 300 millimeters. So, and that standard also has a supplementary note that 760 millimeters can be reduced to 730 millimeters in specific instances. However, and then there is the TSI requirement that we're also complying with the infrastructure TSI that requires a 760 millimeter separation between the rail and the platform edge. However, this TSI doesn't define a platform recess width. So during construction, it was found that this 760 millimeters couldn't be achieved throughout the whole length of the platform. There were some specific locations where the constructed recess didn't meet that 300 millimeter requirement for the recess within the NIR standard. We as part of the process then we went to look at this change to see if we needed to make modifications and if the practical engineering solution was available, and also assess what the constructed element was and to see whether the risk was still reduced as far as reasonably practicable. So with the constructed element, it was found that even though in order to maintain the TSI compliance of 760 millimeters, even though we would not keep the 300 millimeters recess to the platform edge. So that's the far right diagram. You would in effect still retain that 300 millimeter safe area, because the distance between the running rail and the refuge wall would be maintained at that 1030 millimeters that was the minimum required in the NIR standard. So although the individual elements didn't meet the standard, the overall dimensions still remained compliant. So we were therefore able to justify that as through the risk assessment process. So we could demonstrate that the risk was still reduced as far as reasonably practicable. Next slide, please. We also were using slightly two different recognised processes for engineering assurance. So for the rail elements, we were using the NR level 2 0202009 for engineering management for projects, and then for the construction of the main work, so for the building, we were following the REBA plan of work stages through 1 to 8. Both these provide guidance on how the engineering assurance protocols are followed, applied, and managed, but in slightly different ways, and providing the evidence of assurance at slightly different points in time. So we would, whilst these do interface and allow for cross coordination when building this hybrid rail building project, there are challenges in ensuring that they line up at the right point in time for when we need to provide safety justification for the different elements. We managed this through the interdisciplinary coordination and check meetings. So that was used to ensure that the different contractors were coordinating coordinating their designs and builds to allow for integrated safety to be achieved. So they were ensuring that the different disciplines were talking to each other and making sure that their designs integrated safely. These were chaired by the contractor's engineering manager and attended by the relevant design teams, the relevant engineers and project engineers. And these meetings really ensured that the design was coordinated between the different specific disciplines and contractors. And we, as the safety team, worked really closely with the designated project engineer and design manager to ensure that all this correct engineering assurance compliance evidence was available at the point in time that was needed, and so we could use that to demonstrate the safety requirement compliance. And the elements of that differed depending on which discipline we were talking to. So next slide, please. So, for example, the building structures and platforms, they were following REBA, and then they would have their various DRNs, AFC designs, design compliance statements and the ECCs for design, and the construction taking over certificate for construction. The platforms followed a mix of REBA network rail standards, and again had we demonstrated assurance through the DRNs, AFCs, ECCs, and construction takeover certificates. There's various specialist contractors we had on the project, again followed the REBA process, and we again had the DRNs and the AFCs and the construction takeover certificates. But for the rail elements, you can see it's slightly different. We have the P-way, the ST, the MP, they were following the network rail assurance process. So Form A's, Form B's, AFCs, ECCs, and then we're looking at more like the Form 5s and the master test certificates for the construction compliance assurance. Next slide, please. In terms of managing safe operations, we have 3 different teams managing the station. So we've got the rail operations team managing the rail side, the bus operations team managing the bus operations, and the remainder of the building managed by the property department. The operational procedures have been developed to manage the channels of communication, and these were developed jointly between the station ORAT team, the rail operations team, and the bus operations team in a joint working group. and we were able to provide evidence of that in terms of the operational readiness confirmation between the three teams, ensuring the staff received the appropriate training, and demonstration that training was suitable through training exercises that were completed prior to station opening. Next slide, please. So in terms of demonstrating interoperability, we've got the infrastructure TSI, where we had 242 clauses, with which we confirmed about 90 were considered relevant, and the PRM TSI, 343 clauses, approximately 140 of these were considered relevant. For these, we were having to define what phase of the project they were relevant to. Was it the main project? Was it any stage works? Was it or sort of a mixture of that, or both? And then defining what we as the project were, how we were going to comply with those various clauses, and who within the project was responsible for providing that evidence, and then when that evidence would become available. And so that was being defined for each of the relevant clauses. Next slide, please. So that would then go forward through to a clause by clause demonstration of compliance with evidence, that specifically demonstrates that clause compliance at both design, and for some of the clauses, there's also a construction element that's required. So that was quite a big challenge, ensuring that we were making that evidence available to the assessor at an appropriate point in time. Again, we're following through what route to compliance and when that would be available. And then the orange there on the right would be, we would receive that back from the NOBO or DEBO in terms of what the compliance status was and whether they agreed that we were compliant or not. We did have some challenges when demonstrating compliance. So in terms of the building colour scheme is quite grey, so meaning seating, tactiles, window manifestations could blend into the surroundings, so ensuring accessibility contrast requirements. That proved challenging in some cases, and we did need to do some retroactive construction work in a few instances. So the tactiles needed adjustment and things like that to ensure that we had the right contrast requirements. The boundary of the system, so we had on the exterior of the building, due to the nature of ongoing works to the surrounding urban environment, there was a route between various bits of construction hoarding, that we needed to ensure that there was an obstacle-free route and PRM compliant lighting all the way through that hoarding out into the public realm. And the reason we needed that was due to the phase nature of the project, and making sure that those external areas fed through to the public realm. And then we also had challenges, as Lisa mentioned, around ongoing construction in parallel to the various third-party assessments being needed to be done. So it was really key to understand when those various bits of construction were going to be completed, so we could line up everybody for a quick turnaround in order to achieve the entry into service date. Next slide, please. So as I mentioned before, we were able to achieve some interoperability exemptions under Regulation 13 for the command control and signalling TSI, and that was approved by the Safety Authority following us able to demonstrate that the basic parameters specified by the CCS TSI that are relevant to upgrading a Class B signalling system that we were doing for BTH was appropriately managed through TransLink codes of practice and application of CSM RA to the clauses that were relevant. We weren't introducing any new features like ETCS on this project, so we were able to get that exemption approved by the DFI. And then we also were gained an exemption to the requirement for 2 specific infrastructure TSI clauses for the Blackstaff culvert. And this is where there's a diverted culvert passes underneath the new railway. And we sought these exemption to these 2 clauses because the infrastructure TSI wasn't specified in the design when the culvert was built back in 2017. And as a result, the evidence for compliance to the TSI wasn't available, and it wasn't possible to demonstrate that compliance retrospectively without significant disruptive works. But we managed to demonstrate that the culvert was strong enough to the culvert was compatible with all the loads that are expected or expected on Northern Ireland infrastructure. So in Northern Ireland there is no freight, it's only passenger services, and the TSI assumes that there will be a mixed modal traffic. So we were able to demonstrate that because there was only passenger traffic, the actual loads experienced by the culvert would be less than what the TSI requires, and therefore we were able to demonstrate that the culvert was suitable for use. It had already been demonstrated to be sufficient for use for the actual loads expected in Northern Ireland, and therefore it was safe to operate, but it just wouldn't be compliant with these 2 clauses. And that rationale was accepted by the DFI, and we got that exemption approved. And next slide, please. So overall, through collaboration between all the project stakeholders, we were able to successfully demonstrate that the BTH change to the railway was integrated safely and was interoperable. So we achieved supportive safety assessments from all the ASBO, the NOBO, and the DBO. We got our declaration of safety accepted by the DSMM, so that's equivalent to NRAP SRP in Network Rail terms. And then we gained Safety Authority approval authorization to enter into service, as Lisa mentioned, October last year. And that went really well. And that's it from me. I think that's the end. Thank you very much.
Thank you very much, Andrew and Lisa, for the excellent presentation. And I see that there's no questions yet on the Q&A panel, so I will start by asking a question of my own. And I was wondering what standards applied to the building of the rail elements of the station, and you mentioned it was Network Rail standards. And I asked because not only does Ireland have a different gauge to Britain, but also that it has, it has to interoperate with Irish Rail. So could you tell me more? Could you, Andrew or Lisa, tell me more about that, please?
Yeah. So in terms of Northern Ireland, so on the whole, Northern Ireland, what's the right word? They bring in Network Rail standards as far as practicable, but they do review and adjust the standards to accommodate for the different gauge. So they have their own gauge, so 1600 millimeter wide track, and their own vehicle gauge there. So that's the main difference. And sort of, so just the parts of the Network Rail standards that are relevant to that are adjusted for Northern Ireland, but on the whole, they will bring in the relevant Network Rail standards. And I think Lisa, you might, I don't know if you want to add to that. You're on mute, Lisa.
Apologies. Yes, no, you're 100% right. We largely apply the Network Rail standards, but that is a classic example where, you know, our gauge will be different. And obviously from that enterprise train that travels from Belfast to Dublin, therefore we have to be compatible from the same gauge point of view. So yeah, that's where a classic example where we would have a difference and our own NIR standard in place.
Thank you very much, Andrew and Lisa. I see that there's not been any questions yet posted on the Q&A. So if you do have a question, please type it into the Q&A panel and I will pose it to our presenters. With that in mind, I do have another question which I was thinking about. I've lost my train of thought. No, I've probably lost it. Anyway, I'll publish a question, I think from John Dolan. John Dolan says, I think one of the most impressive bridges changes is the direct access over the bus bridge between Belfast Grand Central and the motorway. Really makes a difference for Gold Line heading south.
Yeah, so that was a big change and also a big challenge on the project. I've chatted about like the rail blockade, where we extensive period where we had to shut down the rail in order to do the blockade. But from a bus operations point of view, it never had a blockade. It continuously ran the services. Andrew touched on it there. In order to get the works to work in parallel and also as a program. The busway bridge was brought forward, but you would have seen in one of my pictures there, like it's quite a constrained site, so you can see it just there where the cursor's running, and that basically takes the services straight out onto the Westlink, and that again has timetabling advantages, and therefore from a public point of view, it reduces kind of getting caught into city centre traffic and straight onto the motorway site. So yeah, it's good from a connectivity point of view, and it gets you heading south towards Lisbon direction, Dublin, etc., rather than having to do a loop around in Grosvenor Road and go down a public slip road onto the motorway.
Thank you very much. And I do remember my question now. So my question will be about, so this station is currently unelectrified, as is the railway across the island of Ireland. But my question would then be that what would the interoperability and CSM process have to take place in order to allow for overhead line electrification? So question being that, was it worth, for example, just getting all of that, all of the CSM and RIR out of the way now, for if there was to be ever electrified, or was it not worth it until the wires go up?
No, it's a good question. Like, you're always trying to forward plan, and I think Andrew would say, I think one of the hardest challenges for us, we needed a lot of help to understand, because a lot of the business, we hadn't gone through this scale of change before. So things that we would have thought took X amount of time did take longer. And Andrew touched on the amount of information from the different people and the right people that was required at the right time. That was a huge challenge. So I can see why you'd start the process earlier. The problem is electrification. There's a lot of unknowns at the moment at this point in time. So yeah, I think that would be kind of a key challenge. But it would also just touch on electrification. There's a lot of future proofing in the station. So we have built in for that change. A good classic example is the 3-a-day pedestrian bridge structure, increasing the heights across that structure to allow for future electrification. The supports on the central cantilever system of the platform also allows for additional loading if we needed to add electrification loading onto those platform. So there's little things like that we've done, but yeah, it's a good point. I don't know, Andrew, if you want to come in, like I can see where the forward thinking would be a good idea, but I also feel at this point in time, there's just a lot of unknowns at this point in time too.
Yeah, no, I think you touched on pretty well. So I think, yeah, there was forward planning where it was possible. So, you know, some of the longer life aspects, you know, like the bridges and structures, you can future proof, but it's really difficult to, apart from for the CSM regulations, you're demonstrating that the system that you are going to enter into use is safe. You aren't looking at potential hazards for a system that isn't yet there, because you obviously can't demonstrate that you've removed, you know, you've managed those risks yet, because you don't know what the system will look like until that change is being enacted. So there's various things that you can do for future proofing, but from a CSM point of view, what you are focused on is managing the change that you are making. You don't know what the electrification, what all the, you know, obviously, you know, some of the key ones like, you know, electrocution and things, but you can't manage the system change until you know exactly what you're bringing into use, and that's too unknown at the moment.
Thank you very much, Andrew and Lisa. And John Dolan has corrected me in saying that Ireland has electrification in the Dublin area, 1500 volt DC overhead. Thank you, John. I just didn't think of that. I was only thinking of the general long distance rail in Ireland. And with no further questions in the Q&A panel, my last question to you both, but mainly to Lisa, would be what's TransLink's plans for the future? Are there any plans for extending public transport, buses, rails, I don't know, light rail, spaceship?
No, they're like the all island strategy is kind of a good indication of where we would like to go to in the future, 100%. So that's like looking at maybe airport links. That's kind of key thing that came out. Like none of the airports in any of the island of Ireland are serviced by rail, so that's kind of a key thing that came out of that report. The electrification line between Belfast and Dublin is strongly being looked at the moment, which kind of hits on your point. And John Dolan's referring to like the DART services that goes further north, which is electrified. So yeah, there is plenty in the pipeline. It just all needs funding. Those are the points.
Right. Thank you very much. On behalf of the attendees and on behalf of the RCEA, I would like to thank you both, Andrew and Lisa, for this excellent presentation. And for the members of the audience, I will be uploading this recording onto our RCEA YouTube page. The link will then be made available in our RCEA members archive, and also it will be shared in the post-event email that Kath Coldwell will send out. Thank you very much. Have a good evening.
Thank you all.
Thank you.
Much appreciated.
Thank you. Yeah. Good evening.